All right, this video is going to be about the other two spring mass problems. We did the one in class where we solved this equation. This was on page 74. We solved this equation, we got the general, and then we did one initial condition where it was pulled down 4 inches and with initial velocity of 2 feet per second, and we said down was positive. We're extending the spring, so that's logical. You could as easily have it the other direction, you just have a different solution, but it would describe the same motion, just describing positive to be up. All right, so we're going to do 3 and 4 today. So let's take a look at 3 here. We've got x of t, again, it's going to be the same equation. We're just going to have a different a. This one is pulled down 4 inches, so the initial position is still 4 inches, which is 1/3 of a foot. But now it's released with an initial velocity of 2 feet per second directed upward. So in our case, upward is in the negative direction, so it's negative 2 feet per second. So let's use those to find our a and b. So x of 0 will be a times cosine of 0 plus b times sine of 0, which will equal 1/3. B sine of 0 is still 0, so a is 1/3 again. X prime of t will be, let's see, negative 8a sine 8t plus 8b cosine of 8t, and x prime of 0, let's see, will be negative 8a sine of 0, that's just 0, plus 8b cosine of 0, that's equal to negative 2. So b will be negative 1/4. So this tells me that x of t is 1/3 cosine of 8t minus 1/4 sine of 8t. Now, what I'd like to do again is I'd like to convert, I think, did I have it here? I mean, we want to convert to a similar form that we did in number 2. We want to find the c, we want to find the alpha. So that's our next challenge. So we're going to do a triangle. This time, though, the a is positive, but the b is negative. So we are actually down in quadrant 2. We have 1/3 and negative 1/4. And then alpha, remember, alpha is between 0 and 2 pi. So alpha is this angle on the outside there. So c is the same, square root of a squared plus b squared. That's going to be the same, the square root of 1/3 squared. Because we're squaring, the fact that the b was negative this time doesn't matter, so we're still going to get 5/12. If we do the arctangent of b over a, that'll be the arctangent of, let's see, negative 1/4 over 1/3. So that's the arctangent of negative 3/4. That is not alpha. That's actually this angle, but it's in the negative direction. So to get alpha, we have to loop all the way around. So alpha is actually this plus 2 pi. So that's a little tricky there. You got to think carefully about that. So in this case, then, x of t will be the c, which is 5/12 cosine of omega t. Let me put a bracket there because cosine of omega t minus, and then our alpha is arctangent of negative 3/4 plus 2 pi. I'm going to leave the frequency, amplitude, period, and time lag for you. Those are pretty straightforward. The only one that's actually different is the time lag on this one. All right, and let's do the similar one here for number 4. Now it's pushed 4 inches above, so since we defined positive to be down, this will actually be a negative initial position. X of 0 will be negative 4 inches, or negative 1/3 of a foot. And x prime of 0 is 2 feet per second directed downward, which is extending the spring. So the way we define that, that's positive 2 feet per second. And so again, we start the same. X of 0 is a cosine of 0 plus b sine of 0, which is 0, equals negative 1/3. So in this case, a is negative 1/3. And we've got our x prime above here. So x prime at 0 will be negative 8a sine of 0 plus 8b cosine of 0. And that should be positive 2. So this part is 0. Cosine of 0 is 1, so divide by 8, b is positive a fourth. So let's go ahead and jump. I mean, I guess we could write it here. We know the form is going to be negative 1/3 cosine of 8t plus 1/4 sine of 8t. So again, we need to find the c and the alpha, so we'll do a little drawing. This time the a is negative and the b is positive, so we are over here in quadrant 2. Negative 1/3, positive 1/4. Again, alpha is not the internal angle. Alpha is between 0 and 2 pi, so it's always measured from the positive axis there, just like a radian measure of an angle. All right, so c is again going to be 5/12, so I'll let you calculate that, but it doesn't matter that the a is negative. Alpha, let's see, it's going to be arctangent of b over a, but that's going to be, let's see, arctangent will be between negative pi over 2 and pi over 2. This is going to be a negative number, so it's going to be a negative angle. It's actually going to be this angle. This is the arctangent of b over a. So to get alpha, why don't you think about that while I write down what's going to go here, or maybe you subtract. So let me write down this while you think about how you can convert that. So just like the last one, we have arctangent of negative 3/4, but now we want to add, did you figure it out? We want to add pi, right? Plus pi. So then our x of t, our position equation, 5/12 times the cosine of omega t, 8t, minus, and then in this case it's arctangent of negative 3/4 plus pi. And again, I'll let you think about the amplitude, frequency, period, and time lag. The only difference really is time lag, because the amplitude is still 5/12, the omega is still 8, so the frequency and period are going to be the same. The only thing different is alpha, and so the time lag will be the only difference. All right, so hopefully that is helpful to see those two worked out.